Good afternoon, everybody. This is Dave Doddridge, DA Doddridge and Associates, Inc. So before we get started in this, I just want to talk a little bit about what I do with respect to stairway accidents, single-step accidents, and accidents that occur on ramps. There are a lot of personal injuries that occur in these walking surfaces, and there's more to a ramp or a stairway than might meet the eye. In other words, a stairway may look perfectly safe when in fact it isn't. There's a lot more involved in the safe design and construction of a stairway than you might think, such as dimensional uniformity issues. We're going to be getting into all of that. So let's jump right into this. The goals and objectives of this webinar. We're going to go into what you should do as an attorney when you first get a slip, trip, and fall case, and that advice comes from a lot of my clients who I asked, attorney clients that I asked what to look for, what advice can I give people. We're going to review codes related to stairways and ramps. We're going to review methods of testing stair tread for slip resistance. We're going to get into various definitions of portions of a stairway, what the difference between static and dynamic coefficients of friction are, commonly found defects, and review of other walking surfaces. So, what should you do as an attorney when you first get a slip, trip, or fall case? And again, this comes from the advice of my attorney clients. Go to the scene, take pictures from all angles. The more the merrier, really. You want to try to memorialize the scene as accurately as you can and as soon as you can before it changes. Sit and observe the scene yourself for maybe not 20 minutes, but just stand and watch. If it's a busy location, you'll see people, how they use it. Maybe make a note of the weather conditions, of course, if it's an outside stairway or if it's an inside stairway that's in close proximity to an outside door. Maybe some contaminants of water, whatever, had migrated into the stairway area. Obviously, ask the client if there were any witnesses. Get an immediate statement. Interview employees. If it's in a retail location, maybe they might give you some clues as to other accidents that have occurred and why. Check the status of the owner. Find out who the owner or the lessee is. Find out if the owner is a corporation and who the shareholders are. Find out if the lease is recorded. Find out if the lessee is responsible for maintenance and repairs. Go to the city hall, find out if the business is registered and to whom, find out who the owner of the business is, name and manager of the business, emergency room records, read them before hiring an expert. Oftentimes doctors use templates that have like a checklist that could state something like fell at home when in fact the plaintiff fell at a supermarket. So you have to be aware of that. In that case, you would be forced to get a note from the doctor stating exactly what the plaintiff said. The more time that goes by, the more difficult that's going to be. Find a stairway expert, such as myself, through agencies such as the Expert Institute, directory listings, Google searches. Avoid using a hired gun, which is something that in the expert witnessing industry is something that I certainly avoid. And I am still very much involved in the construction industry and in the commercial building inspection industry. So my time that I spend weekly as an expert witness is really only about maybe 15% or so, because I'm busy doing other things that are related to my area of expertise. Become your own expert, educate yourself. Obviously, you have to know if you have a case before you spend the money hiring an expert. By visiting, observing the scene, interviewing witnesses and employees, performing research at the City Hall and so on, you'll be able to better determine if in fact you have a case or not. Checking local code, zoning ordinances, and that kind of thing, workplace regulations such as state industrial codes and OSHA regulations, to try to figure out yourself if in fact there is a code violation. Some towns require a certificate of fitness before being allowed to rent. So there are local codes that come into play as well. If it's a workplace accident, ask for a copy of the written safety plan, like, for example, on a construction site. The contractor and subcontractors should have safety plans. If there were any safety meetings held, and again, state industrial codes, OSHA, federal OSHA regulations may all apply. Key market segments most affected by slips, trips, and falls: healthcare, aging population, of course, food service, in the back in the kitchen. I've worked in kitchens before, and those floors can certainly get slippery, and it can be a real madhouse. Hospitality industry, lots of people coming in and out. Retail, mercantile, office, transportation, industrial, gaming, and casinos are always packed with people. Escalators, stairways, constantly being used. So what are the causes and contributing factors of stairway accidents? Physiological factors, including balance, aging population. Again, a lot of older people fall. Hearing, vision. We'll get into the lack of a visual cue. In other words, sometimes, and we'll get into a lot of photographs in this presentation as well, which to me are probably the most valuable part of this presentation. Lack of a visual cue indicating that there is a step or a change in elevation, or at the top of a stairway. It's sometimes difficult to tell that it even exists, that a stairway even exists. Environmental issues such as flooring, lighting, hazards, things that are in the way, handrail that's sticking out, all sorts of different things that could affect the safety of the stairway. Contaminants on the stair tread surface, such as somebody might have spilled some coffee or some water or some snow or ice or rainwater was migrated in, but just by foot traffic. Lack of dimensional uniformity, and this is kind of a big one with me, and we're going to get into that in some of the pictorials that I will show. So let's move on. Stairway basics, definitions of various components of a stairway. The tread is also known as the step, the surface that is actually stepped upon. The rise is the vertical distance from one tread to the next. The nosing is the, if you look at a stairway perhaps in your home, the tread will stick out slightly beyond the rise, supplying with what's called like a foot space for you, like a toe space. Dimensional uniformity. Codes require that there are maximum variations in tread depth and riser height from one to the next in order to maintain dimensional uniformity for human factors purposes. And again, I've got sketches that we'll go into. Structural integrity. Obviously, a stairway has to be strong enough to support itself and the load that's imposed upon it. The stringers are the angled pieces on the left and right that oftentimes the stair treads are fastened to. So they are typically a structural component. Handrails, obviously the handrails that you grasp as you're ascending or descending the stairs. And I've got sketches of this in here as well. They're to be no greater than 2 inches in width for gripping purposes. A single handrail is typically required in 1- and 2-family structures. However, a handrail is required on both sides of the stairway for commercial buildings. Guardrails are different than a handrail. If you get to the top of a stairway, and there's like a landing there that's considerably high above the floor below, then that is what's known as a guardrail, not a handrail. They are required to be 36 inches in height or more, depending on the height above the floor surface, and to withstand 200 pounds of lateral force. Lighting, of course, is a very important. 1-foot candle is required for most building codes. However, OSHA regulations call for 5 to as high as 10-foot candles to illuminate a stairway in an industrial environment, like say a temporary construction stairs or something like that. Landings, obviously, the top or between flights of stairs. Types of stairs, many different types of stairs. We've all seen them. Straight run stair, which is just what it says, just goes straight up. Spiral stairs, metal pan stairs, scissor stairs, alternating tread stairs, winder stairs. Those are all different types of stairs. So here we get into some visuals. This is a cross-sectional diagram of a typical straight run stairway. Okay, so here's an exploded view. This is the nosing. This is the part that sticks out on the tread beyond the rise, and this provides a little foot space. Now on commercial stairways, the rise is angled up like this. Okay, so so as to not provide a little catch spot that you might actually trip on as you're ascending the stairway. This is the tread width. 11¼ is a typical dimension. Headroom, this is 80 inches, and that is measured vertically from the from the leading edge of the treads. So, and that is a typical headroom for a stairway, particularly in a 1- and 2-family residence. In commercial, sometimes the code requires more. So we get into a spiral stairway. We've all seen these. I'm not a big fan of them. In my opinion, they're pretty dangerous, but they do exist. There are codes with regards to the dimensions of spiral stairways as well. This is a typical metal pan stairway, and I'll show you what I mean by metal pan stairway. They're usually used in commercial applications. I believe I have this is one that's under construction. The reason why it's called a metal pan stairway is because right in here, this is the tread. It's not filled in yet, so it's like a pan. OSHA regulations do not allow a worker or a stairway to be accessible until these pans are filled in, typically filled in with concrete, and then maybe covered with tile. If it's a temporary, if you want to fill them in temporarily, then you'll see on construction sites, you'll see pieces of wood fitted in here. So this does not provide a tripping hazard, but rather is flush from one tread to the next. This is a typical scissor stair. You can tell by looking at it why it's called a scissor stair. So here we have a good example, the handrail that comes up at a certain height, usually 34 or 32 to 38 inches, I believe, measured vertically off the leading edge of the treads. And then you come up and you get to a landing. So this over in here is going to be referred to as a guardrail. Okay, the guardrail has to meet certain guardrail requirements. I'm not a big fan of these either. These are pretty dangerous. This is known as an alternating tread stairway, and it's a space saver. Obviously not used really in residential, but more in industrial applications. And there are some specific codes with respect to the amount of floor space that a stairway like this is allowed to serve. Naturally, this is a stairway that is not going to accommodate a high foot traffic. So winder stairs, I'm sure we've all seen these. These are there's some very specific codes with respect to winder stairs as well, and I'll get into the specifics of that as we proceed. Okay, now codes. IBC is known as the International Building Code. It's written by an organization called the International Code Council, and these are known as model codes, and states and local states will adopt these model codes as their own. So let's get into a little bit of what this code says with regards to the stairways that we just looked at. Spiral stairways are permitted in residential dwelling units and commercial buildings serving an area of not more than 250 square feet, which is pretty small. So in a commercial application, the stairway, a spiral stairway cannot lead to an area that's greater than 250 square feet. The treads of a spiral stairway have certain measurements that code regulates. So let's jump back to a spiral stairway right here. When you measure out along this rise 12 inches, okay, the depth of the tread in this direction at a right angle to that 12-inch measurement cannot fall below, I believe, 7.5 inches. So in other words, the tread of a spiral stairway, when measured from that narrow point 12 inches out, cannot be less than 7.5 inches deep at that point. The overall minimum width of a spiral stairway tread is 26 inches. So it can't, the treads themselves cannot be less than that. Building code continued. Well, this first one is an OSHA regulation, OSHA Part 1926, which regulates the construction industry, does not allow, as I mentioned earlier, the use of pan stairway by workers until the pans are filled with concrete or temporary wood filler piece. One of the reasons why I included this in this presentation is because I do a lot of construction accident work, and this happens all the time. A worker will be walking down or up a metal pan stairway that's not filled in, and their foot will catch on an edge, and they'll trip and they'll fall. Alternating tread stairways, much like the spiral stairways, are only allowed to serve a fairly small area, and they're limited to their use in factory, high hazard, and storage buildings. Again, not more than 250 square feet. So, like, say, a storage area or something like that. Okay. Alternating tread stairways are also allowed for use in institutional buildings, such as prisons, serving a guard tower, observation room, or control room not more than 250 square feet. So these are very specific regulations with regards to these types of stairs. And one of the reasons why I put the alternating tread stairway in this presentation is because you don't see them that often, and I thought it would be sort of interesting to have that in here, just to illustrate the various types of stairways that exist. Winder treads are required to have a minimum tread depth of 11 inches measured at a right angle to the leading edge of the treads at a point 12 inches from the narrowest side. Okay, so just like I illustrated just a minute ago on the spiral stairway, so let's go back to this is a winder stair. So if you measure 12 inches out along this vertical rise here, then at a right angle to the leading edge of this tread, it has to measure 11 inches deep at a point that's 12 inches out from the narrowest side. So these code regulations are pretty specific with regards to dimensions, and this is not something that is necessarily going to be all that obvious by looking at it. It's not going to be obvious until you actually measure and analyze the stairway. Okay, so all right, so let's get into the slip resistance of a stair tread, which is also known as the coefficient of friction. So what is it? What is the coefficient of friction? In engineering terms, it's defined as the force required to move two sliding surfaces over each other divided by the force holding them together. And I'll simplify that in a minute. Static coefficient of friction means that the object is stationary. Dynamic coefficient of friction refers to objects that are in motion. So to put it in simpler terms, for the purposes of this presentation, a coefficient is a number that is used as a constant or a multiplier. So therefore, if an object weighs 100 pounds and the static coefficient of friction is 0.50, you take 100 pounds, multiply by 0.50. It would therefore take 50 pounds of lateral force placed laterally against the object to cause it to break free from its static position and slide along the surface that it's sitting upon. So it's really fairly simple for the purposes of this presentation. Some building codes and the Americans with Disabilities Act accessibility guidelines recommend a coefficient of friction that is 0.50 or greater, although they are not typically enforced. And why is that? Because in order to determine the coefficient of friction of a surface, walking surface, or the surface of a ramp or a stairway after it's been built requires testing, and it's just not practical for like a building inspector to test the coefficient of friction of a floor surface, and it's just not a practical thing to do. So therefore, it's not actually enforced with regards to the testing of that surface. So therefore, most building codes simply state that non-skid or slip-resistant materials are to be used. And you have to remember, the lower the number, the more slippery the surface, because the less amount of lateral force against the object is required. So therefore, the surface that the object is sitting upon is more slippery. So this is a tribometer, also known as a slip meter, also known in generic terms as a drag sled. I have this particular instrument. And basically, the way it operates is, if you see this little metal tab sticking out here, there are very specific calibration instructions and whatnot that you have to calibrate it before each use. But what you do is there's a ring that's attached to a vinyl line, and you simply pull it, and this is spring-loaded inside the mechanism, and when it breaks free of its static position and actually moves, it records the amount of lateral force that was required to make it move. There are other types of tribometers available that are more sophisticated, less sophisticated, but I don't want to get too far into that for the purposes of this presentation. So this is an actual case that I had. As you can see, the coefficient of friction is showing here as 0.61. This is on in a subway station, and you can see the yellow non-skid, quote, non-skid tape that was applied to the leading edge of this tread, and where it was worn is actually quite slippery. So it's really not doing a whole heck of a lot of good. Obviously, in a subway station, there's a tremendous amount of foot traffic. So okay, so codes and standards. Various local, state, and federal governments require stairs and ramps to meet certain requirements. For example, the International Code Council is what I was discussing earlier, and they author and publish what are called model codes that are then adopted by states. Most states in the country now are adopting ICC codes, and there's a variety of them. There's the IBC, which is the International Building Code, IRC, which is the International Residential Code. There is the IPMC, which is the International Property Maintenance Code. And that deals with the maintenance, including the safety, of course, of existing buildings. Okay, so, and then of course there's the Americans with Disabilities Act. The accessibility guidelines are what regulate ramps and communication devices, elevators, that kind of thing. OSHA, of course, Occupational Safety Health Administration. American Society of Testing Materials, the ASTM, publishes what are called industry standards. There's an industry standard that they publish that I use actually quite often, and I will go into that shortly. And obviously this is not a complete list. Building codes are typically grandfathered. The reason why I'm bringing this up is because if a building were built 80 years ago and the code in place at that time required certain things of a stairway, out of a stairway with regards to dimensions, handrails, any number of different things, as long as it met the code that was in place at that time, and there has not been a change of use within the building, then the stairway remains code compliant. You can't expect, as codes change, you can't expect building owners to upgrade their stairways, obviously, as codes change. What triggers code compliance is the change of use. For example, if the building is converted from a mercantile use group to an assembly use group, such as maybe a retail store being converted into a restaurant, then that change of use will trigger code compliance. Okay, there are variances that can be granted if there's space restrictions or lot line restrictions. It can get fairly complicated, but that's typically what will trigger code compliance, is the change of use of a building or a space. Okay, so the International Code Council, as I discussed earlier, used to be known as BOCA, which stands for Building Officials and Code Administrators. BOCA joined forces with a couple of other code authoring agencies and formed the International Code Council. And as I discussed earlier, ICC codes are adopted as building codes by most states. So therefore, as a result of that, building codes are becoming very universalized. So they're pretty much the same from one state to the next. The only, especially with respect to things like stairways, the only difference is that, like for example, Rhode Island will have adopted the International Building Code 2006 with Rhode Island amendments. So those amendments are specific to Rhode Island, and they might have to do with wind loads or things that are specific to Rhode Island. But with respect to something like a stairway, those are quite universalized from one state to the next. Within these codes are what are called referenced standards, such as those developed by ANSI, American National Standards Institute, ASTM, which I discussed earlier. The reason why these referenced standards are used within these codes is because those standards have already been written and tested. So what they do is they will say that the fire sprinklers are to meet, NFPA such and such, and that's it. So they don't have to reinvent the wheel. They simply use these standards as referenced standards within the code. Here's some examples of stairway and ramp requirements that are found within the International Building Code. For example, ramps are supposed to have a slope of not more than 1 inch vertical for each 12 inches horizontal. So if you measure 12 inches horizontally, the rise cannot be more than 1 inch. Stairways in commercial buildings are to have a maximum rise. So this is like a riser and tread type stairway, not a ramp, of course, of 7 inches, and a minimum rise of 4 inches. And the reason why that is, you would think that the less the rise, the less the tripping hazard. That's not necessarily true. If it's less than 4 inches, then you really oftentimes can't even see it. You can't even tell that it's even there. So there is a minimum rise requirement as well. 1 and 2 family buildings require a maximum rise of 7 3/4. Not long ago, that was actually 8 1/4. So again, as building codes are changed, you can't expect stairways to change. Stair treads, minimum tread depth of 11 inches for commercial buildings, as I illustrated in that cross-sectional diagram earlier, and I think that one was 11 1/4 inches. The headroom, again, as I had shown in that diagram, of 80 inches is the minimum requirement for headroom. Okay, stairways must be a minimum of 44 inches wide That's in commercial buildings, unless the occupant load is less than 50, in which case the minimum stairway width is to be 36 inches. 50 is a pretty small number, so typically in a decent-sized commercial building, you're going to find that the stairways are certainly wider than 36 inches, 44 minimum. And here we get into codes with respect to dimensional uniformity, and I run into this a lot. I've got some pretty good pictures in here that I can use as examples, but in other words, the height of one rise cannot vary more than 3/8 of an inch from the one that is adjacent to it. It sounds like a small number, but it actually isn't. Treads are to be level within 2-inch slopes. So naturally, if you're walking up the stairway, you want the stair treads, the surface that you're stepping upon, to be level. But it's a fairly small surface. It's only 11 inches wide, so therefore it can have a little bit of a slope to it, but not more than 2%. Handrails, as I said, are required on each side of a stairway in a commercial building. Handrail height above the stair treads, no less than 34 inches, but no greater than 38 inches. And that actually has changed a little bit recently too. So the strength of the handrails and guardrails is to be designed to resist a concentrated load of at least 200 pounds. Obviously to prevent somebody from falling through it. There are also codes regulating the width of a handrail, or what I call the graspability of a handrail, and I've got some good sketches with respect to that coming up. Codes for stairways in historic buildings are sometimes grandfathered and therefore excluded from compliance with current codes, and that's sort of an unusual point. The reason I put that in there is because I was at a building, actually I think it was a law firm in Connecticut, and the office was in an old historic building, and the stairway and handrails were original to the building, and I believe the building was originally built as a residential, and then of course they converted it to office space. But because of its historic nature and the location of the stairway within the building and all that kind of thing, they got a variance to exclude that stairway from being compliant with current code. So that does happen, I guess, is my point. Other codes, such as state and local housing codes, international property maintenance code, etc., deal with the proper maintenance of stairways in commercial and residential buildings. You have to understand that the building codes do not necessarily go into a lot of detail with regards to an existing building. Building codes are written for the purpose of planning a building and constructing a building. But once that building is built, there haven't been too many codes related to the maintenance of those buildings. So the International Code Council published the International Property Maintenance Code, and it's actually pretty good. So, for example, like say in Massachusetts, and I'm sure other states as well, if you have an apartment building, let's say it's a 4-family apartment building, and there's a stairway that only serves one apartment, then the tenant, as long as it's in the lease agreement, is responsible for snow and ice removal. If that stairway serves more than one apartment, let's say it's an outside stairway, then it is the landlord that is responsible for making sure that the snow and ice is removed. So, and of course, objects cannot be placed on a stairway so as to not impede the safe use of the stairway. So you can't have boxes or, toys or whatever on a stairway. Okay, here's a sketch of a landing. This is a landing on a typical scissor stairway, as I showed in the photograph earlier. So as you come up the stairs, go across the landing, and then go up the stairs in this direction. So there are codes with respect to how much a door that's located within that landing can swing into the landing, how much space it's allowed to take away from the landing when it's in use. Again, right here, and this is from an ICC code. This deals with landing width. Landing widths, in other words, this direction here, left to right, cannot be, landings are to have a width not less than that of the stairway or door, whichever is greater, okay? So if this stairway in this direction, left to right, is 44 inches, then the landing has to be 44 inches. When the door is in the open position, it should not reduce the required width or depth of a landing by more than 7 inches. So this little space in here cannot be more than 7 inches. So therefore the door in the planning of a building has to be located in the right spot so as to make sure that the stairway and landing is code compliant. Landings minimum of 44 inches in length of the direction of travel, which is in this direction, front to back, except they may be 36 inches in residential occupancies. And once again, for occupant loads of 50 or more, the door in any position may not reduce the width of the landing to less than half of its required width. So that's what this dimension here is. When the door is in use, it cannot reduce the width of the landing by more than 1/2. So those are codes related to landings. Okay, so here we get into handrails. And this is important, and I know that there's, it seems like a lot, just for a handrail, but the minimum diameter of 1 1/4 inches, maximum diameter of 2 inches. That's for a round handrail like this one here. Other shapes of equivalent graspability are acceptable. Railings that do not have a circular profile, okay, shall have a perimeter dimension of at least 4 inches, but no greater than 6 1/4 inches, and a maximum cross-section dimension of 2 1/4 inches. Okay, so the handrail space, so that your fingers can fit and you can fully grasp the handrail. So there's a code for that, 1 1/2 inches minimum off the wall. And then, of course, the amount of space that the handrail itself can take from the width of the stairway. It cannot project into the stairway by more than 4 1/2 inches. So there are some very specific codes related to all these dimensions. And again, when you stand and look at a stairway, it might look safe, but once you start to take various dimensions, you might find all sorts of code violations that could render it unsafe and not in compliance with code. The location of handrails, the number of handrails that are required. Only those portions of a stairway width within 30 inches, okay, 30 inches away from this handrail may count toward the width required for egress capacity. The egress capacity is based on the occupancy load, okay? So let's say that this stairway is 60 inches in width, okay? And the occupancy load requires that dimension of the stairway. That means that that the portion of the stairway that is within 30 inches of this handrail is the only portion of the stairway that will count toward the required width. If this stairway were 8 feet across, okay, because the occupancy load dictated that they needed a stairway that was that wide, then you'll find a handrail going in the middle, because again, only that within 30 inches of the handrail counts toward the width of the stairway with respect to the occupancy load. Okay, handrails are to be continuous, so they cannot be interrupted, and I actually have a couple of good photographs, I think, with respect to that. So more on codes and standards. The ADA-AG requires ramps to have a slope no more than 1 inch vertical and 12-inch horizontal, so that matches the ICC code regulations. ADA guidelines recommend a coefficient of friction on ramps to be 0.80 or greater, which is pretty skid resistant. But again, there's that word recommend, so they don't. It's not a regulation because it's not tested, okay, and therefore really not enforced. Aside from the ADA, there are state and local government regulations that can also have regulations regarding accessibility. So there's federal codes, there's state codes, and there's local codes. Accessibility codes can also be grandfathered in sometimes. Occupational Safety and Health Administration relative to stairways. Construction safety, OSHA regulations for construction safety require stairways 30 inches or higher to have at least one handrail. Okay. Temporary stairways for construction sites are required to be between 30 and 50-degree angle from horizontal, and that's pretty generous. But again, it's a temporary stairway. It's not a permanent stairway. But it's interesting, riser height and tread depth are not to vary more than 1/4 of an inch throughout the stairway. So here you have this temporary stairway on a construction site that's going to get torn apart, but it still has to be built fairly accurately. As a matter of fact, that 1/4 inch is less than the 3/8 inch regulation in the International Code Council building codes. All right, so there are other codes and standards that have requirements related to stairways and ramps, walking surfaces, and this is not a completely comprehensive list, of course, but here are some more. American National Standards Institute, known as ANSI, American Society of Safety Engineers, Uniform Federal Accessibility Standards, Fair Housing Act, HUD, ASTM. So there's quite a few codes, standards, regulations that have to do with proper stairway construction. So this is the standard that I was speaking of earlier. ASTM, American Society of Testing and Materials, has a standard known as F1637, Standard Practice for Safe Walking Surfaces. And it's a pretty well-written, comprehensive standard. The scope of the standard, of course, to cover design and construction guidelines and minimum maintenance criteria for new and existing buildings and structures. So, and is intended to provide reasonably safe walking surfaces for pedestrians wearing ordinary footwear, and I believe that's a quote directly from that standard. This is a standard that I use fairly often, and it's one of the few that references the a visual cue, or the demarcation of the leading edge of a step or a platform where there is a change in elevation. And I've got some photographs coming up where I can show some pretty good examples of that. So again, that ASTM standard F1637 addresses flooring, walkways, and also is intended to address all these different things: carpeting, changes in level, mats and runners, lighting, headroom, exterior walkways, hardware, stairs and single steps, which a lot of codes and standards do not address. I'm referring to the single steps, speed bumps, wheel stops, gratings, and warnings. So it's a pretty comprehensive standard. Okay, so following are some visual examples of stairway, ramp, and single-step hazards. So we're going to take a look at some full-height stairways, shorter stairways, single-steps, curb ramps, brick walkways, and entrances. So these are actual cases that I did. So you might look at this as a layperson, and you might say, okay, it looks like a reasonably safe stairway. And while its structural integrity may be intact, there are a lot of things wrong with this stairway. The first thing that should jump out at you is the amount of the rise of this lower step is much less than all of the other rises contained within the stairway. So as you're walking down the stairs and you're used to, say, 7.5 inches, 7.5 inches, 7 3/8 inches as you descend the stairway, and then all of a sudden it's 5 inches. So your foot hits the ground much sooner than expected, and add a little bit of ice to the bottom of this stairway, and it can make for a very hazardous situation. And actually, one of my clients hired me to evaluate the stairway because that's exactly what happened. But there's other things as well. There's no handrail in here, and I know and I'm not sure if this is I think it might be a two-family. There should be a guardrail in here, because as you ascend the stairway, you're getting to, 3, 4, 5 feet up off the ground. And while an adult may not fall in there, a child certainly could. This handrail is made out of a 2x4, which is 3.5 inches in width, which is considerably wider than that allowed by code. Okay? So again, the height of this first rise is much less than the height of these other rises. So it really just throws you off, throws the user of the stairway off as you're descending the stairway. This is one of my favorite stairways, but not really. There's everything wrong with this stairway. It's in an industrial location. While the lighting was good, take a close look. I mean, what do you see? You see no handrail up against this wall, right? You see a handrail on this side that is a 2x4 that is 3.5 inches in width, which is much wider than that allowed by code. But as you get into it, there's a lack of structural integrity right there, if I've ever seen it. The nail from this stair tread going down into this stringer probably split as soon as they put it in, and they just didn't do anything about it. Right here, where it's fastened to the top, is pulling away from the frame. So that obviously is not structurally sound. This isn't a great photograph. I apologize for that. But the vertical rise of this top rise was, when I measured it, considerably higher than the rest. So there's dimensional non-uniformity throughout this stairway, as well as all these other hazards. This landing is not flush with this door sill, and in commercial applications they're supposed to be. I've got some other photographs coming up that illustrate that pretty well. So this is a step immediately down at the door, which is a big no-no. Here we have a tread, and then we have this single board that is placed on this step that exists nowhere else in the stairway. I'm not sure why they even put that on there, but when I was talking about nosing earlier, the nosing is to project beyond the rise by 1 1/4 inches. Well, this is just the opposite. The nosing stands behind this rise. So this is just a very, very poorly constructed stairway, and just an accident waiting to happen, which is exactly what did happen. Here we have, looks can be pretty deceiving. This is in a residential condo that was being rented. This newel post right here, it took very little force when you grabbed it to move this thing a lot in both directions. I mean, this thing was really, really weak and very wobbly. And that is because of the way it was constructed. I unfortunately don't have a picture of that in this presentation, but if you bear with me here, the bottom of this newel post, when you construct a railing, the newel post has to be fastened to the frame of the building in order to provide strength. Well, all the carpenter did was just cut it off and toenail it to this piece of oak flooring here. So as this piece of oak flooring loosened, so did the handrail. It's just a very poor job of constructing the stairway here, or the guardrail. This handrail here against the wall is supposed to be continuous. It's supposed to go up, over, and up, and be continuous from top to bottom. So when she came around, grabbed the newel post, and it was extremely loose, and she fell down the stairs, she had nothing to grab onto. So again, looks can be deceiving, as with this one here as well. This is a ATM kiosk owned by a major bank. This walking surface on the outside is not flush with this walking surface on the inside. So there's an immediate step at this door. And that's a no-no. That is a code violation. So basically what happened was a woman opened this door and went to enter the kiosk, and the door closing speed was pretty high. And so the door sort of came slamming shut behind her, essentially sort of pushing her into the building. And there we have another code violation right here, and this is what's known as an object in the path of travel. This is a very small little ATM kiosk, right? It's not big at all. But here's this shelf that's right inside the doorway. So she came falling in this doorway and fractured her larynx right on this corner here. So she literally landed with her throat right on this corner. And of course, I've been back to the same ATM kiosk years later to use it, and I took a look at everything, and nothing has changed. The door closing speed has not been adjusted. Nothing has been changed on this, interestingly. So now this may look fine, right? Looks can be deceiving. Here we have this main ramp right here was in compliance with code, okay? It met the 1 inch in 12 or maybe a little less slope requirements, but this ramp over here is considerably steeper, and I'm sure that they did this because they were limited with respect to the amount of space. So this ramp here, you add a little bit of snow and ice on this, and if it's too steep, then that can prove to be a hazardous situation. As a matter of fact, my client in this case was himself an attorney, and he ended up right down here lying on the pavement for quite some time before anybody realized that he couldn't get up. So, you know, again, looks can be deceiving. This is in Manhattan. There's a ramp right here that leads to a building. And this step right here, this little step right here, it's not really a step, but this little ledge right here was 1.5 inches high. And again, that brings us back to that the 4-inch minimum requirements. Not that you would put a 4-inch step here, but the point is that it's so small you can't see it. And so a gentleman was coming up and he tripped on this and fell and I think fractured his wrist or an ankle or something like that. And it really would not have taken anything other than a little attention to detail for whomever it was that installed this ramp to make sure that it was flush. This should be flush to within, say, like 1/4 of an inch. And I know these dimensions that I'm discussing sound relatively small, but not necessarily. A little can go a long way with regards to this kind of thing. So, again, looks can be deceiving, and I did not take this picture. If I did take this picture, it would have been from a different angle. But if you can imagine yourself as a pedestrian coming through this lobby and walking in this direction, whoops, sorry about that, walking in this direction, and this surface here on this landing and on all the steps leading down was made of the exact same material. There's no demarcation, there's no visual cue that there's a change in elevation along this leading edge. And as a matter of fact, the tile guy, when he tiled this, probably stood back and said, wow, these grout lines line up perfectly with each other. Well, okay, but that can create the illusion of a continuous floor coming from the direction of descent. So somebody was walking in this direction, and because the grout lines all line up and the material is exactly the same from one surface to the next, they couldn't see the change in elevation, and they went tumbling down the stairway. All right, in this case, looks cannot be deceiving because this is one of the worst stairways I've seen. Everything is wrong with this thing. No landing, it's very steep, The rise from one rise to the next is way too high. The width of the treads is too low. The handrail is too wide, and there was no lighting. I mean, it went on and on and on. So when I looked at this stairway, I took into consideration that this is in an urban environment. There's a building fairly close to the stairway opposite this brick building here, and so I sort of asked myself, you know, did they have room enough to build a landing out here and simply have the stairway come off that landing parallel with the building, so that way you would have a landing to stand upon and room enough for a properly dimensioned stairway coming off that landing safely to the ground. And the back of this building actually contained a bunch of these same stairways. So, you know, just laziness or, you know, budgetary issues, you know, didn't want to spend the money to do it properly. So this is another good example of where the walking surface, the landing outside the door, should be flush, and I get a lot of these, with the inside walking surface right here. And it isn't. There's a step immediately at the door. This is a big apartment complex here. And the woman had just gotten out of knee replacement surgery, called the management company ahead of time and asked them if they could make preparations for her to get safely through this doorway. They didn't make any preparations, and as she was being helped through the doorway, her foot caught on, I believe, the metal threshold of the door, and her knee actually went back in the opposite direction that it's supposed to be in. So I know some of these cases that I'm discussing are pretty serious injuries, and so this is the day that she got out of the hospital, and this happened. So people just, you know, building owners really need to be aware of these kinds of things. This is a pretty good example of a couple of different things. This door was propped open because it was a warm summer day, and so therefore it was sort of like a continuous path of travel leading directly into the building, and we have this little less than 4-inch trip step here as a result, and it's made of the same materials as the walking surface is made of. So you really can't even see that it's there. And a gentleman came along, and with the door being open, he really didn't even slow down, and he just fell right into the building. So it may not look like much, but these things do happen, especially with people who might be physically impaired, maybe older, maybe visually impaired a little bit. Not everybody is athletic and able to recover from these things. So just wondering how much time I have left here. It's already 3 o'clock, sorry. I know we got a little bit of a late start, just about done. Here we have a very similar circumstance. Outside landing is not flush with the inside, and somebody fell into the building. This is a curb ramp, a good example of the lack of a visual cue along this leading edge here. You really can't tell under certain lighting conditions that this little curb is here. And a woman came walking along, she didn't see it, tripped and slammed her head on this concrete planter. So I'm going to show you now something with proper visual cue. You know, if you can't see that there's a change in elevation here, then you know they did a good job making sure that there's plenty of visual cues here to warn people of the existence of a change in elevation. Okay. We're almost done. This is just poor choice of materials. This is in a restaurant. Brick walkway, cobblestone edging, uneven surfaces. A gentleman was coming in and the tip of his cane got caught and he fell and broke his hip. And this is a tool that I used in this particular case to measure the depth of that depression. It's very difficult to do with like a tape measure. So this is a scribing tool that is used in carpentry, and you press it down against the work, and it takes the shape of whatever it is that you're pressing it against. And that's how I determined what the depth of that was. So again, short stairway. I'm going to wrap this up because we're running out of time. But these posts here, these vertical posts that hold up the canopy above, impede the handrail. So this handrail is supposed to be unobstructed, and there's 4 posts that are literally welded to that handrail. So this is interesting only in that this is a wood stairway, right? And look at the coefficient of friction, 0.10 dry, okay, which is extraordinarily low and therefore very slippery. So it might look okay, but it's not. So, all right, that is the end, and I hope you all enjoyed this. Now let's move on to the Q&A here. One question regarding an appearingly unsafe stairway to the second level of a building with apartments on the second level. When one goes up the stairs, one must step down a step or two to open the door at the top of the landing in order to enter the second floor. I'm not sure if I completely understand. I'm trying to visualize that in my head, but that certainly should not be the case. There should be a landing there flush with the sill of that door. And so if you have to actually step down and maybe bend over to open up that door, then that is certainly not in compliance. Our client fell down the cement steps, was severely injured, and died a week later. Oh gosh. Stairway was also dimly lit. After the deceased mother came to us, she took photos. The owners removed the door at the top of the landing and installed new lights. The issue with the entrance onto the second floor is my concern as to safety codes and standards. Any feedback? It's difficult to visualize this specific situation in my mind, but certainly if you have to step a couple of steps down to open a door, then that should not be. So the best way for me to tell that is with photographs. Let me see some other questions that we might have here. Is there a coefficient of friction requirement for ramps as well? In particular, I'm interested in handicapped ramps. As I stated earlier, I think I've already answered that question. The ADA AG recommends 0.80 or higher, which again is pretty high, as it well should be. Can I have the brand and model number of the red colored digital tribometer shown? That is an ASM 825A. It's made by American Slip Meter. That's what the ASM stands for. In your experience, is there a higher standard of care with entrances and exits specifically designed to satisfy the requirements of the ADA? Higher standard of care. I wouldn't call it a higher standard of care. I suppose you could. Sometimes the handicapped entrance is separate, of course, from other entrances, but you do have to. There are some very, very specific regulations that the ADA requires to be met. So I don't know if I would call it a higher standard of care. I would really just call it a requirement to meet those regulations. Does there reach a point after the accident when there is no longer a benefit to the expert visiting the site? Yes, like in construction accidents, construction sites change daily. So when I get a construction accident, I really never go there because there's no reason to. There's nothing to see. It's not a construction site anymore because it happened 5 years ago or 2 years ago, whatever the case may be. If it's an existing retail store, say, or whatever it may be, you want to get the expert out there as soon as you can, as long as you've made up your mind that you're going to hire one and who it is that you're going to hire. But you want to document that scene preferably through the eyes of an expert as soon as you can. But as an attorney, feel free to document it yourself, but that doesn't necessarily mean that you're going to know exactly what to look for. Hopefully this presentation will allow you to know what to look for. Maybe you'll take a tape measure with you and take some dimensions and some pictures and that kind of thing. When I evaluate a stairway, I bring my tribometer with me, I bring my light meter with me, I bring a laser level with me, I bring all these different tools with me, which obviously not everybody's going to possess or know how to use. So hopefully that answers that question. Give pointers of changes that should be made, ATM versus the yellow lines shown near the end. Does this come up in litigation? Some of the cases, some of the reports that I've written certainly point to the lack of a visual cue, particularly on single steps. Nobody really thinks that it's necessary. If it's, say it's a 4-inch or a 5-inch curb ramp, and who's going to think that anything's really going to happen on such a small space? But it does. So a good property manager will know that a visual cue should be used in order to provide pedestrians with the proper warning of a change in elevation. So, so yes, that certainly does come up in litigation. Let's see here. Thank you, Debbie. You explained the landing issue in your seminar as well, the lighting and okay, very good. And I think I'm on my final question now. What about situations with interior inclined anti-skid metal surface ramp that's wet and slippery due to tracked in rainwater, pedestrians' shoes? Interior inclined anti-skid metal surface ramp. Yeah, I know what you're talking about. It should be dry, or there should be a walk-off mat. These walk-off mats or a doormat that you see, those are designed to, as you are walking across them, those are designed to actually remove the contaminants from the shoes. So by the time you get to the end of that mat, your shoes are much cleaner than they were when you came in. So perhaps there should have been a mat in front of that ramp or something like that. As far as footwear is concerned, I don't want to speak beyond my area of expertise. I'm not a shoe expert, so there are a million different types of shoes. So that sort of goes without saying. And we have another question. It's good to see people are still on board here. What is the effect generally of the plaintiff holding a stack of papers falling stairs with one short tread? Holding stack of papers falling stairs. Not sure what's meant by that. If the plaintiff is in a commercial location, office building, or say the actually that's exactly what happened on my favorite stairway that I quote unquote showed earlier. The woman was carrying a box because the office was moving, I believe. She's probably holding it with two hands. I think it was a box of papers that she was holding. So, and she just, you know, if you're focused on holding that and you don't have a free hand to grasp a handrail or something like that, then naturally that's going to make it a more hazardous circumstance. So, not sure if I answered that question correctly or not. Boots for icy weather and slipping comes up. How do you deal with faulty design and footwear as an issue? Again, there are other companies that know more about footwear than I do, so I don't want to speak beyond my area of expertise with regards to you know, the types of soles, the types of materials that are used in in the construction of a shoe. So I would have to pass that along to somebody who knows more about footwear than I do. How to address grandfathered violations that violate newer codes but not code at time of construction. Again, that has to do with what code was in place at the time of the building's construction, and since that building was constructed, has the building or a space within the building been reclassified to a different use group. Building codes go by a number of different things, including hazard indexes, types of construction, occupancy loads, use groups, and all that kind of thing. So commercial building codes can actually get very complicated. So if there has been no change of use or any major renovation to the space, that might also trigger current code compliance. But as long as there's been no change of use, then whatever building code that was in place at the time of the construction of the building is still the one that would apply to that building. Right? So that is the last question. I hope everybody learned something from this today. Hopefully you'll be able to take away some information that will help you in determining if you have a case or not. So, and Frank, thanks to you as well.
Great, David, thanks so much for the presentation today. And everyone, we will be sharing the presentation slides and the video recording in the coming week. So stay tuned, and thanks again, everybody.
All right, thank you.